Let's get started. In the last class, we have started descriptive geometry. The key thing that we have to remember is if I have a plane on which I want to generate a view, then the true length can only be measured in the view, which is parallel to the line. I brought my toy again. See this frame? What I am saying is, let's say I have a plane. Let's say the horizontal plane. If I have a line which is parallel to the horizontal plane, then in the horizontal plane, please listen to me. That is the key, okay? Otherwise, you will feel that the concept is very abstract. The horizontal plane is parallel to my line, this line. The pencil is my line. And it doesn't matter what kind of orientation I have for the line, so long as my horizontal plane is parallel to my line, then I can view this line quickly and to see its true length. We can extend that idea saying that any plane which is parallel to the line, then in that plane, I can see the true length of the line. Okay, let's say this is a front view. If I have a line here, parallel to the front view, and you can see the true length. Doesn't matter how I rotate, you can see the true length. You can see the true length. So that is the key. In order to measure or find out the true length of a line, then the condition is you must have a plane which is parallel to your line. Okay, so if that is understandable, then what we did last time was this. You see, I have a horizontal view, H, indicating that a horizontal view, and the front view, F, indicating this is a front view. Then this supporting line saying that my horizontal view is perpendicular to the front view. No doubt about it. And also, we have said the front view is actually a elevation view in which we can measure the height. Actually, all those views perpendicular to the horizontal view is elevation view, in which I can measure the height. That's another point that I have made. So if that's so, then this is an elevation view, this is a horizontal view. They are perpendicular to each other. And my fording line there to distinguish those two planes. And I have said we can use fording line to indicate that. Now, I don't know CD or CD here in the front view or horizontal view are the true length or not. Usually they are not. But I can be very sure if I can draw a line here, draw a line parallel to the CD line there, and call this one a fording line, then I'm saying I am generating a elevation view which is perpendicular to the horizontal view. See, this is H, this is H, so everything is H. This plane is H. The other side would be an elevation view, which is perpendicular to the horizontal, in which I can measure the height. Then we use the principle of projection that we have learned, saying that, okay, in the elevation view, if I draw a line, principle of projection, then I know this D point in this elevation view must be along this line, just like a front view, right? You can see I draw a line there, then perpendicular to the 40 line, which is the 40 line dividing those two planes, then I can find C, I can find D here. Same, exact same idea. And I draw a line perpendicular to the 40 line, and I know the C point must be somewhere there. Where? Then we have to use the concept that I just said. In any elevation view, I may measure the height of the feature, or the line, point, a plane. So I have two elevation views in this case. This is horizontal view. This is elevation view perpendicular to the horizontal view. This is another elevation view, also perpendicular to this horizontal view. Therefore, the height, C. C is here. C is there. So I can mark it there. C is there. And D, in the elevation view, measure the elevation, the height, D. But you have to measure from the horizontal, from the horizontal plane or the 40 line. Okay. Then I may say, okay, here, that is the true length, because I know my elevation view is generated in such a way it is parallel to the line. So this guy must be true length. True length. Okay, this is D, this is C, point C. True length. That's how we find it. So if you want to enhance the memory that we have just generated here, and say that, okay, I have a horizontal plane here, and in the front view, then you can see a line CD. Horizontal plane, I can see the line CD, but different view, but same line. And if I want to find out the true length of the line, I cut perpendicular to the horizontal plane another line, in which I can see the true length. Then you're actually seeing it in that. Right? Okay. So that is the fundamental we have to remember. Then the rest of the concepts are based on this. If that's so, then we can say we can state another concept, which is slope of a line. Slope of a line. Slope of a line is the angle. The angle between the line and horizontal plane. We measure the slope. Let's say I have a line in space. How do I measure the slope? Then I measure the angle between the horizontal plane and my line. Between the horizontal plane and my line. That's how we define it. That's not enough. There are a few points that I have to emphasize here clearly. First of all, this angle, okay, the angle must be between the horizontal plane and a true length view. True length view. If you do not see the true length in a elevation view, then you are not measuring the slope. Slope, first of all, is measured between horizontal plane and your line. But that's not the measure in any view. It must be, the angle must be measured in the view in which you can see the true length. So true length view is a must. Secondly, the angle that you measure, we call it the slope, must be an angle smaller than 90 degrees. Then you can say that's the slope. So anytime you declare a slope of a line, then there must be a horizontal plane. Must be a horizontal plane. You must have a horizontal plane, then you can measure the angle which we declare as the slope. Secondly, to measure the angle precisely, you must measure it in the view. You can see the true length, or we can call it the true length view. In the true length view, then you can measure the angle between the line and the horizontal, which is the precisely the slope. Of course, there are two angles, right? You have a horizontal plane, you have a line, and this angle is smaller than this angle, then you use this smaller, less than that. Okay, if that's all, then we can do the measurement here. Protractor, and saying that, oh, okay, I have and I can say, well, I extend this line, or you just imagine that you extend that line. And from that point, you can do the measurement by saying that probably somewhere around 17 degrees for this one. 17 degrees. Let's check whether or not I am following this concept. Is this true length? Yes. Is this plane what we call horizontal? Yes. Is this less than 90 degrees? Yes. It is. Right. That's how we do it. So, as you can see, this concept is based on the concept of true length. We must have true length, and we must know how to draw true length. How? Generate a plane which is parallel to the line. That's it. In that view, in that plane, you see true length. Of course, I know you need exercise. Okay, another point that I want to make is point view. Point view. This is all related to the characteristics of a line. Point view. In short, I write PT. Oh, what I'm doing. PV. PT is something else. PV. Okay, point view. Point view. What we meant by point view is, if I have a line in space and I want to find a view in which I see this line is a point. That is the view we call point. Let me say it again. Point of view is a view in which you see a line as a point. Okay. Let's say physically it is easy to recognize that. Let's say I have a line here in space. If I want to view it as a point, then I must have a view this way. Then I will see this line as a point. That implies my picture plane is what? It's a plane perpendicular to this line. In other words, if I want to generate a point of view, then I must have a view which is perpendicular to the line. Let's just write down it. We can also say this is a view perpendicular to the line. That's what we want to find out. Well, you see a line in space, you have a different plane, may say different length, right? The longest length would be true length. Other views will see the shorter one, or even the point. If you have a view which is perpendicular to the line, then in that view, you can only see a point. Okay, if that is our concept, then what I should say, let's say here, I do an exercise here. See, I have a front view, horizontal view, and the line 5, 6. If I want to find the true length, then I generate a plane or elevation view parallel to line 5, 6. Then I say, well, 5, 6 is here, perpendicular to the 14 line. This is the 14 line. This is my 14 line. 14 line. And 14 line. And then find the elevation, because I have generated an elevation view. 5, 6. 5, distance is here from the 14 line. 5. This is a 5. 6. 6. From the 14 line again, but you must be very careful. This is my 6. Then I draw a line connecting 5 and 6. That is my true length. And then you may generate a, let's say, I use different colors, so many lines joined together. I mean, probably to move it, but too late now. Okay, you can do either side, this side or that side, doesn't matter. So then I can say, oh, there is a line here. Imagine that I can extend it. And then I draw a line perpendicular to it. That means I have a plane perpendicular to the line 5, 6. Must be perpendicular. Well, you can do it properly or better than I am doing. Just showing you the concept. Okay, so my point view must be somewhere along this green line. This green line. Then, what is the height? Then I'm assuming that this this whole thing here is a plane. You imagine that's a horizontal plane. And this is the elevation view, this is the elevation view too. Elevation view is perpendicular to the horizontal view. Well, actually any view. Then I can say, oh, that's so. I have the elevation here. I can measure, must be the same. From 5 to 6, 5, 6 is parallel to it. Then I can say, oh, I have there. This point is a point on which 5 and 6, the two ends of the line, are overlapping with each other. That is my point B. Have a look. You see, I have drawn a plane here, that's floating line, to generate the true length. That's a true length view. This is my true length view. And the distance there for the point of view is measured from here. Exact same idea as we have used as the elevation view. You may call that as an elevation. That's okay. Or the distance, the same. Because this view and that view sharing the same plane, which can be considered as a horizontal. Sharing means this plane and that plane are both perpendicular to this point. Of course, the elevation can be measured. Then you can find the point. As an exercise, we may also find the point of view for this line, which is CD line that we have just generated. In order to do that, you may do it here. Let's say we do it this way. We extend this one, and perpendicular to it must be perpendicular. And I know the CD must be along that line. Then, since this green line is parallel to it, I can measure it anywhere. And then my point of view is there. This is my point of view for this line CD. CD are overlapping. Are we okay? Now we have the three concepts: true length, slope, point. I hope that you have written down those. If not, you can always review the video that we are taking. Okay? And do it at home. Do you have some exercise 3 times? I think you should have it. The difficult part is your imagination. You have to imagine that we have space there, which can be described by horizontal view, elevation view, or any view. If you draw a 40 line, that means you have 2 planes perpendicular to each other. And actually in the engineering practice, you may see a lot of parts like that. None of them is perpendicular to each other, perfect perpendicular to each other. In order to describe those features, obviously, you have to somehow graphically describe this true length. You see, this is the shape, true shape, and the length on it can only be seen if you have a plane parallel to it. That's one. And later I will give you some examples. Let's say this one, you only see it, you have a view parallel to it. Same idea. But to give you an idea, what is the relationship between the measures that we have for elevation views and horizontal views, or any views? Let's say I have a horizontal view and a front view. I have finished the process of determining the true length, as you can see there. Width, we know that. Width can be measured in the front view and top view, horizontal views. Width, height can be measured in any elevation. And the depth can be measured in top view, or in this case, it's horizontal. Actually, you can prove, well, I can easily prove mathematically. H squared plus W squared plus D squared is the true length squared. And the square root is the true. That also tells you why the length of the true length is the longest in comparing with the length that you can see for the same line in some other views. Okay, that's the relationship. Another thing that I may describe today is error. Bearing. Bearing, let me write that here. Bearing. Or compass. Bearing. Compass. Bearing, you see, on the surface of the earth, we usually say the location, let's say the location of the Parliament building is northwest from the university. That is bearing. The location, sub-location, with respect to the location that I am standing, that is the bearing. Key point is that you are standing on the horizontal plane. You assume you are standing on the horizontal plane. So what we are saying, you see, on the Google map or what kind of map, then you will say, well, if there's a location, there's a location. Well, where's the north? You got to have an arrow to indicate that's north, right? Then you will say, well, north, west, east, south. Key point is that if you talk about north, west, east, those kind of orientation or direction, you are assuming that you are standing on a horizontal plane, or you are describing the orientation with respect to a horizontal plane. So what I should write here, measure on a horizontal plane, or we can say it's a plan view or horizontal. In the future, if we say plan view, you are saying horizontal. Or if you want to extend your imagination, you can say that is a view that I am viewing on a helicopter. Same idea. So in the future, if you are talking about north, west, east, those kind of ideas, the first thing that you have to recognize is we are talking about the directions on the horizontal plane. You must have a horizontal plane or plan view. Then you can describe it. If that is understandable, then I would like you to copy down this. The angle. We want to, as an engineer, we want to describe any numerical quantities precisely. You cannot say northwest, southeast. That's not very precise. Let's say AC, for example. AC, we write in this form. Please write it down. In the future, we have to use it. Okay? South, we write south, and the angle is 52 degrees. South, 52 east. If I have a line in space, and I want to know the orientation of the line in the horizontal plane or plan view, then I have to do this. For AC is south, of course that's south. North is this direction, right? We have an indication of north. North, south. South, 52 degrees east, 12 east. Then the orientation of the line in the horizontal plane is precisely and uniquely determined. This angle, again, the bearing angle is also less than 90 degrees. Also less than 90 degrees. Let's say AB. AB is a line north. North, but the north is this way. North, 30 degrees east. North, 30 degrees east. That's how we write it. That is the bearing. Also, let's say AD. AD, south. 45 degrees west. South, 45 degrees west. And AE, of course, that's north, west. North, 60 degrees west. I don't know how many times that I have to emphasize here. Those ideas, if you talk about north, south, west, east, you are talking about the orientation of a line or a feature on the plan view, or a horizontal line. Or you are doing it on a helicopter and watching down. Or you are doing with the compass on your hand. You have to, your hand must be powered to the horizontal plane in order to identify north, south, east. Same idea. Are we okay? Let's do an exercise. Exercise is very useful. Okay, I don't know how many of you have printed the exercise from your courses, but now you can do it. Let me read it through. You are required to, first of all, finding out the slope of the line, AB. You are also required to find the bearing angle of that line. Do it. Two angles. One is the slope. Then you have to go through the concept that I just described, how you do the measurement for the slope. Second thing is the bearing. Of course, you've got to follow all of the procedures. Do it, and let me see the difficulties that you may have. That everybody should have a protractor in. You got to know which view you may use to measure either the bearing angle or the slope. let's do it together. So the bearing, as I said, must be measured in the horizontal plane. Do I have a horizontal plane? Yes. This is a horizontal plane. So I can measure the bearing there. Then, this is the north. The angle between north-south and my line is the bearing. That is my bearing. Line between north-south and my line, but the angle is my angle. We call it the bearing. The bearing. Okay, then you do the measurement here. Let's say that somewhere there, about 70 degrees. I don't want to do it that accurate, but roughly that's right. So bearing angle is, I can say south, 70 degree east. Or you can say north, 70 degree west. Same. Okay then. Then if I want to find the slope, remember what I said, how to measure the slope? Slope can only be measured in between horizontal plane and your true length. Your true length. So you must have the true length first. In order to do that, you see, you got to cut an elevation view. And then find the elevation of the point A and B. A, elevation is this much. Mark it. And B, AB. Then I draw the line, which is the true length. Then I can measure the angle. Well, they measure the angle, you can extend it, as I said. Well, I ask myself, is this a true length view? Yes, the true length. If this line is, this supporting line is horizontal, it is. See, horizontal, this area is horizontal. It is horizontal. Therefore, this angle must be the slope. Then I will do this. Probably 17 degrees. So then I'm saying slope of line AB is somewhere around 17. Once again, in order to measure the bearing, then you must do it in a horizontal plane. The bearing angle is between your line in horizontal plane and north-south line, only that one. In order to measure the slope, you got to have an elevation view in which you see the true length. The angle is the true length and horizontal. That's all for today. Thank you very much, and good luck for the tomorrow. 9 o'clock. See you tomorrow.
9点的，我操！12点10点钟的事情。辛苦吧，拜拜。